You ever stop and think about what actually happens when you click on a link? I mean, it feels instant, almost like magic. But behind that one simple click, there's this incredible, hidden system of addresses and identities working at lightning speed to make the whole digital world, well, work. Today, we're going to pull back that curtain. Just think about it for a second. If you couldn't get mail or order a pizza to your house, it would be total chaos, right? Packages would get lost, messages would end up who knows where, or maybe they never even arrive. The whole system would just fall apart. Well, believe it or not, the internet has that exact same problem. For your computer to find, say, your favorite website, or for an email to actually land in your inbox, it needs a super precise address. There's this whole sophisticated system just telling every little piece of data where to go, how to get there, and whose it is. Okay, so here's the game plan for tracing that journey. First, we'll look at that world without addresses idea. Then we'll dive into the internet's phonebook, DNS. After that, we'll check out your digital address, or IP, and the unique fingerprint of your device, the MAC address. Then we'll see where websites actually live. And finally, we'll look at the gateway that connects you to the internet. Let's get into it. So yeah, we've already kind of established this, right? A world with no addresses is just chaos. And it's exactly the same online. This whole system, it's not just some nerdy technical detail. It is the absolute bedrock for everything we do, whether you're streaming a movie or sending a super important email for work. And just so you know, the core ideas for this breakdown come from some really fantastic learning materials put together by LeafTech Solutions Learning. They do an awesome job of making these complex topics easy to understand. All right, so our journey really kicks off with the very first thing your computer does when you decide you want to visit a website. See, it has to translate a name that's easy for us humans to remember into a number that machines can actually understand. And that's exactly where something called DNS comes in. So DNS, that stands for Domain Name System. And honestly, the best way to think of it is like the internet's gigantic, always updated phone book. We're good with names, like Google.com, but computers, they much prefer numbers. DNS is basically the translator that looks up the name you type and finds the right number to go with it. And this is a perfect look at that simple little conversation. It's really just 4 steps. You type in the name, your computer pings a DNS server and asks, hey, what's the IP address for this? The DNS server looks it up, finds it, and sends the number back. And it's only then that your browser actually knows where to go to grab the website. I mean, can you imagine if we had to memorize long strings of numbers for every single site? No thanks. Okay, so the DNS did its thing. It gave our computer that magic number. But what is that number exactly? Well, we've just arrived at the next stop on our trip, the IP address. And this, for all intents and purposes, is the digital postal address for every single device that's connected to the internet. Yeah, an IP address, that's short for Internet Protocol Address, is basically what tells the rest of the internet where to send all the data. It's just like how a letter needs a home address to get to you. A little packet of data needs an IP address to find your specific phone or your laptop out of the literal billions of devices out there. Now, here's where it gets kind of interesting. The original system for these addresses was called IPv4, and it can only create about 4.3 billion unique addresses. Now, back in the day, that sounded like a totally insane number. But with pretty much everyone now owning a phone, a laptop, a tablet, you get the picture. We actually started to run out. So the solution to that problem is a new system called IPv6, and you can really see the difference here. The old IPv4 address, it's shorter, just 4 sets of numbers. But the new IPv6 is way longer, it uses letters and numbers, and it gives us a practically unlimited supply of addresses. It's the thing that's future-proofing the internet so we never run out of digital real estate again. Okay, now we're going to go one level deeper. Your IP address, right, that can change. It changes depending on what Wi-Fi network you're connected to. But your device has another address that is totally permanent. It's literally burned into its hardware from the moment it's built. And this is called the MAC address. The MAC address, that's Media Access Control, is given to the device by the manufacturer. It never, ever changes. The absolute best analogy for it is like a serial number, or maybe a unique fingerprint for your device's network hardware. It's a permanent ID. So the most important thing here is to get the difference between the two. Your IP address, that's like your current mailing address. If you move, it changes. But your MAC address, that's like your birth certificate. It is fixed for life. We use IP addresses to send stuff all across the global internet, but MAC addresses are just for devices talking to each other on a local network, like inside your house, on your Wi-Fi. All right, so we figured out how your computer finds a website server using DNS and an IP address. But what about the actual website content? For that, we need to look at the full address we type into the browser, the URL. You know, a URL is actually more than just the name of the website. It's really got three key parts. You have the protocol, like HTTPS, that just sets the rules for communication. Then you've got the domain name, which we've been talking about. That's the name of the server. And finally, you have the path, which tells the server exactly which file or page on that server you're trying to get to. Here's another really good way to think about it to keep things straight. The domain name, that's like the street address of a big apartment building. But all the website's files, the code, the images, all that stuff, they live in a specific apartment inside that building. And that apartment, that's what we call web hosting. Okay, we are at the final piece of this puzzle. Think about it. How do all the different devices in your home, your phone, your laptop, your smart TV, all with their own local addresses, talk to the big public internet using just your one internet connection? How does that work? Well, that's the job of your router. It's really clever. It manages two different kinds of IP addresses. Inside your home network, every device gets what's called a private IP. Nobody on the outside internet can see it. Then your entire home network is represented to the outside world by a single public IP, which you get from your internet provider. Your router is basically the security guard and translator that sits between the two. And that's it, the whole journey from start to finish. So let's just run through it one more time really quick. You type a domain name, DNS finds the IP address for it. That IP address guides the data across the internet. The MAC address handles the final delivery on the local networks. Your router acts as the bridge between your private network and the public web. And the URL points to the exact file you wanted on that server. And all of this happens in literally the blink of an eye. It's incredible. So why does any of this matter? Look, this isn't just knowledge for tech experts. Understanding how this all works is, well, it's just fundamental digital literacy these days. It's the foundation for networking, for online security, for pretty much the entire structure of our modern connected world. It really all comes back to this one core idea, doesn't it? You have to build clarity before you can even begin to tackle complexity. Once you understand these basics, all the other, more advanced stuff about the digital world starts to make a whole lot more sense. So I'll leave you with this one last thought. We've just walked through the rules of this massive global address book that runs our lives. But the real question is, as technology keeps racing forward with things like AI and the Internet of Things, who gets to write the next set of rules? And how are those new rules going to shape our future?